This video is on integration. We're going to discuss antiderivatives, which are also called primitives sometimes. Let's take a function like f1 of x equals x squared. The derivative of x squared is f prime 1 of x, f1 prime of x is 2x. f2 of x is x squared plus 1, its derivative is 2x plus 0, which is x. So this number here doesn't matter, the derivative is still 2x. The derivative of f3, x squared plus pi, is also 2x. And the derivative of x squared plus c is also 2x. So we say the integral of 2x is x squared plus c. And c is just a constant of integration. That means c can be anything. We don't put a number for c. We leave it as c. Okay, so c is just a constant of integration. Okay. The integral of 2x, dx means with respect to x, is x squared plus c. The letter that you use in here doesn't matter. The integral, we're saying with respect to x because we could have done this. The integral of 2a dA, that means with respect to a, will be a squared plus c. Or the integral of 2y dy is y squared plus c. So it doesn't matter what letter you use, it's with respect to. Let's take another function. F of x equals x to the 4 plus c. When you differentiate it, you end up with 4x cubed. So the integral of 4x cubed with respect to x is x to the 4 plus c. Why? Because when you differentiate this, x to the 4 plus c, that gives you 4x cubed. What if 4 wasn't there? The integral of x cubed is x to the 4th over 4 plus c. Because when you differentiate this, you get this. Okay, this is called the integrand. 4x cubed is the integrand. X cubed is the integrand. Integrand. I'm going to give you a table of integrals. There's a bunch of them in here, and this is like a thorough table. It's got most of the integrals you're going to need. I'm not going to say all. I think it got all of them, but just to be on the safe side, let's say most. Okay, for example, if you're integrating 0, the integral is just c. If you integrate a, the integral is ax plus c, and a can be any number. For example, suppose you're integrating 10, the integral of 10 would be 10x plus c. When you integrate x, it's x squared over 2. X squared will give you x cubed over 3. X cubed will give you x to the 4th over 4. So when you integrate x to the power n, that will be x to the power n plus 1 over n plus 1. So what you do, you raise this by 1 and you divide by the same thing. I'm going to do an example here. If they ask you to integrate, let's say, x to the 6th with respect to x, what you do is you raise this by 1. So it will be x to the 6th plus 1, which is 7 over 7 plus c, and then you're done. Because when you differentiate this, that will give you x to the 6th. But n cannot equal minus 1, because when n equals minus 1, you end up with x to the power minus 1, which is 1 over x. We did this in chapter 1. The integral of 1 over x is ln x plus c. The integral of cosine x is sine x, because the derivative of sine x is cosine x, and it's always plus c. The integral of sine x is minus cos x. Secant squared x gives you tangent. The best function to integrate is e to the x, because it's just itself. The integral of e to the x is itself, e to the x plus c. The integral of cosecant squared x is minus cotangent x plus c, and then the integral of a to the power x is a to the x over ln a plus c. When you're integrating a function, if you have a number in front of the function, you can always pull that number out. For example, if you're integrating, let's say, 2 cos x, well, don't bother with the 2, just take it out. 2. And then the integral of cos x is sine x plus c. And then when you integrate the sum of two functions, f of x plus g of x, you can separate the two integrals. That's integral of f of x plus integral of g of x with respect to x. And let's do some examples. In the first example, you are integrating x squared minus 8x cubed plus 3x. So you integrate each term separately. X squared, add 1 to 2, so that will be x cubed over 3 minus, take the 8 out. For x cubed, the integral is x to the 4th over 4 plus 3. And then the integral of x is x squared over 2. Okay, x cubed over 3 minus 8 over 4 is 2x to the 4th plus 3 halves of x squared plus c at the end. I didn't need to put it in this step. You could if you want, but make sure you put it at the end. And that's the result. When you integrate 4 square root of x, square root of x is x to the power half. Take the 4 out, integral of x to the half. So for a half, you do 1 half plus 1 over the same thing. So it will be 4x to the power 3 halves over 3 halves. And that will be 8/3 of x to the power 3 halves plus c. Here's another one. 3x squared, etc. So this will be 3x cubed over 3. Minus 5. The integral of x to the 4th is x to the 5th over 5. I kept them as derivatives. Plus 4 times the integral of this, which is tangent x, equals x cubed, the 3's cancel, minus x to the 5th, plus 4 times tangent x plus c. The integral of e to the x minus cos x, we do those separately. So for e to the x, the integral is just itself, e to the x, minus the integral of cosine x is sine x plus c. And if you have something like this, there's no quotient rule for integration. So for this particular integral, you just separate the two terms. So you write x cubed over x squared alone minus 4x over x squared alone. X cubed over x squared is just x. Minus 4, x over x squared is 1 over x. And the integral of x is x squared over 2 minus 4 times the integral of 1 over x is ln x plus c. So that's what you do with this to simplify it. If we have more terms in the denominator, that's a different lecture. We're going to use a different method called the U substitution or some kind of a substitution to simplify.